Hello, everybody. Um, Welcome to this session on how to approach Cambridge maths as a South African homeschooler, which is oddly specific. It's I've done a couple of these over the years, um, and I thought it's probably about time I do one for maths. As exam results have just come out, and I've had a lot of parents contact me. Um, Wondering, like, is Cambridge really right for them? How do we do this thing? Why is it that no matter how hard the students worked, they just didn't really get the results that they were wanting? Some of these were at school, some of these were working on their own, some of these had tutors. Um, and the thing is, I really just want to reset expectations a little bit. Cambridge doesn't work very well with exam coaching. Um, from a South African context, we understand caps and stuff like that, and exam coaching works really well in caps. Um, it's I loved being exam coached in high school. We used to have a teacher that specifically, like, people would pay her just so that they could coach them through a specific exam set, and they do really well, even if they didn't really understand the content. Now, in Cambridge, it's not really going to happen very easily. You could maybe make an argument for it at IGCSE, but at AS level or A level, you're just not going to manage to do it. I was going to live stream this, but I thought it would be it would be better to just be here, and I'm pre-recording this and I'm in the chat for conversation. Now, Cambridge maths isn't harder really than other types of maths. Maths is maths, but it isn't very forgiving of shallow learning. So when I was at school, if we could just get through a basic concept, we'd at least be able to get like 60, 70. And then if you really understood, you'd get 90. Cambridge is not like that. Shallow learning, you're just going to get ungraded. If you don't know what you're doing, you're just not going to manage. So most of our struggles are coming from confusing covering the work with understanding the work. So just because you've gone through the textbook doesn't mean you actually understand what's going on. So the way that I approach this, the way that I approach maths and pretty much everything, is using the trivium and quadrivium. So today I want to talk about the quadrivium, how we deal with numbers, and a possible way that you might be able to deal with numbers for yourself and in your homeschooling. I tried a bunch of different things. This is the one that lasts. It's with the one that lasts. And yeah, it's built in Greek philosophy. And it's really where Cambridge thinking came from, like how the exams are set up, how the schooling system is set up, how traditional schooling and universities are set up, was built on the ideas of the trivium and the quadrivium. So when the biggest thing I've noticed is that when students come to me, all of their weak foundations, like when they're primary school, all of those compound, and then by the time they get to AS or IGCSE, it just becomes like absolute panic. So I want to today just work through how we deal with the primary years, how we work with IGCSE, how we work with AS. And this is just not how we, specifically Marinus, this is my recommendation for how to approach these things in a way that's mindful, that actually gets you understanding it a little bit better. So let's just quickly look at the classical framework. I did mention it. But the classical framework, we've got the trivium. So the trivium, trivium. The trivium, if we apply to maths, we've got, well, really, the trivium is made up of grammar, logic, and your rhetoric. So if we apply it to maths, your grammar would be your symbols, your notation, your operations, your number sets, the very basics. How numbers work, how do we make these things work together? This is playing with numbers. As in primary school, it's playing with numbers, enjoying having number games, jumping around the garden, counting, stuff like that. But then it progresses onto multiplication, addition, subtraction, division. But then we've also got our notation of different ways to write things. So this doesn't really end when we're young. Like even at like an IGCSE level, you're learning new notations. And this is your grammar. This is your language that you use to approach maths. So your logic then from there, so you go from your grammar, you need the grammar, you need the understanding of the basics. Then we go to our logic, and this is the why of everything. So why do these methods work? We've been taught methods. Why do they work? It's playing around with the relationships. It's playing around with the structure. And it's really learning to prove things. Like in everything, we need to be able to prove. When we say 3 is equal to 4x, we need to, what we're doing by showing our working out is we're proving what's happening. We're proving it. So then we go to rhetoric, which is your layer a little bit deeper than that. And we look at our solutions. So we explain our solutions. So not just your proof-like thinking, but being able to actually explain it. And I've got a really handy trick for primary school that I do with my kids. But it's also the modeling, it's the interpretation, it's the exam communication, because we might understand it, we might be able to do the logic, but we need to be able to communicate it in an exam for the examiner to know, hey, they do get it. Okay, so it's taking it a step further. Okay, now if a child cannot explain a method, they don't own it, they don't get it. Okay, they might be able to use it, but if they can't explain it, they don't own it. And I would say, even for me, if I can't explain a concept, I don't own it yet. And so I don't think personally the way that I approach maths, the way that I approach maths is that there is no, you can do things wrong. You can be wrong in maths, and that is okay. And so many people are like, oh no, but there are no stupid questions and stuff like that. And generally, yes. But the reality is that there is a right answer and a wrong answer. How you get to it is your own journey. There might be a more efficient way to get there, and there might be a less efficient way to get there, but that doesn't really matter as much as being able to explain, hey, this is what I did, this is why I did it. And so from the trivium, let's go a little bit deeper. We've got the quadrivium. Okay, so the quadrivium, quad is 4. Quadrivium is made up of your arithmetic, your geometry, your music, and your astronomy, which sounds weird, like, but just bear with me for a moment. Okay, so your arithmetic is, we all know that one. So it's your primary and lower secondary foundation. So we're really working through the counting, the working with numbers. Okay, then we make it a little bit more abstract by moving into geometry. Okay, and this is we look at space, and we look at how space is used. We look at shapes and how they work together. We look at visual reasoning. And so what was that thing? It was Singapore maths. Singapore maths has a lot of visual reasoning, and that actually includes, it takes our arithmetic and adds a component of geometry with the visual reasoning. Then we've got, so that's when we have primary to IGCSE. So it gets a little bit more complicated later on. But then we have music. Okay, now music, how does it relate to maths? I promise it does. So music is your ratios and your patterns. Now things in maths that are ratios and patterns are algebra, sequences, functions. They're representations of things. This is music. This is a level of maths. This then we've got astronomy. So astronomy, the study of how stars move and planets align and whatever. Well, stars don't move, but the the movement of astral bodies, celestial bodies. But this is your change in motion. So we're looking at how things change, how they change in relation to each other. And so we're looking at calculus, we're looking at mechanics, statistics. All of these change and work according to what's around them. So it's very contextualized. Okay. So astronomy is basically your contextualized maths. So yeah. Now, when we look at primary maths, I've got a bunch of children of my own, a whole plethora of them. But I've got a bunch of children of my own, and they're actually none of them, okay, none of the homeschooled ones are at the same level as their age level suggests they should be. So my daughter is at her age level in maths. But in English, she's far beyond her age level. My son is at his age level in English and language. Okay, maybe a little bit ahead in language, above his age level in language. But in terms of maths, he sometimes comes into my room and gives me a maths question. He's like, I'm sure your IGCSE students have not thought of this question before. And then he gives a question, and then I'm like, hey guys, do you guys want to do this? And then we work through the question because it's actually kind of what they're doing at the time. And he might not have all the arithmetic foundation, and he might not have all the grammar to go with it. So he can't necessarily, he doesn't have the words to explain, but he's got enough of the vocab to be able to explore. And that's where the curiosity comes from. And so we can approach it from a curious perspective instead of constantly having this intense structure of read through the textbook. So some common mistakes when it comes to primary maths that people make is a massive over reliance on worksheets, and rushing through abstract notation. So when we look at notation and how we write things down, how we show our working, that is a process all on its own. We shouldn't rush through it. Let your kids explore it. Let them have fun with it. Have a whiteboard, have a blackboard. I've got a blackboard in my lounge and I've got a whiteboard in my passage. And the kids are constantly doing maths on there. And drawing pictures. But I mean, same thing. Same thing, really. So we don't want to be rushing their abstract notation. Also, their verbal reasoning and play. That is so, so, so important. So we should not be ignoring that and pretending it's not important. Because when my son comes to me and he's like, okay, Enoch made this mistake. The reason he made this mistake was because of this. If he had just made this decision, then he would have done that. And then we're like, okay, but like, would he have known to make that decision because he didn't have the context that you had? And that doesn't feel like maths, but I promise you it is. Things like chess, that builds your reasoning. It builds your math skills. So these are things. Don't rush through childhood just so you can get them to write an exam. It doesn't really matter. Give them a childhood. Give them a childhood filled with maths. Sometimes my daughter will come to me. My daughter will come to me and she'll say, well, can we have cupcakes? And she's still in primary school, and I'm like, well, I don't have a recipe. I don't know what we've got in the cupboard. Figure it out and make it. And she's currently 9. So, yeah, just let them play. And if they mess it up, then they mess it up, and we'll accidentally turn the cupcakes into brownies or something. I don't know. So what we should focus on instead of these like worksheets and stuff, we need to be focusing on a couple of things. So number bonds and place value, very, very important. So I have a Zettelkasten. I don't know, nerdy people might know what that is. Um, so I have a very specific filing system for my notes. And I used to have it on my computer, and then I was like, oh no, I'm going paper based. And so I moved backwards and I started the paper based system for my filing. And it was very interesting because my filing goes 1 and then 1A and then 1A1, 1A2, 1A3, and it goes like that. So my son was really struggling with this idea, and he's currently 7. And I thought, you know what, let's just let him figure it out. So I sat with him, and it took him about 3 hours to just figure it out. And he used that somehow as the basis for place value, because he was like, okay, well, this has a higher value. This 1 has a higher value than this A, but I don't even have to look at if I've got a choice between 1A1 and 1B1. Obviously, it doesn't really matter because B has a higher place value. And so we started playing with that a lot. Number bonds, started that at like 4. It's just going through life. A fun game that we used to play, and we still sometimes play, but now my kids love rhyming games in the car, is adding the digits on the numbers on a number plate together. Then we've got estimation and mental maths. So we go to the shop, and when we go to the shop, I have them. They do groceries with me, and they have to basically add up in their heads more or less what things are. They don't have to, but they do, because otherwise I'm going to win. Because when we get to the till, then we each say how much we think it's going to be, and then the person who wins. You win nothing, but I mean, you win because you win. And so we do that, and that's mental maths. It's estimation. It's fun. Okay. And then we've got. Okay. Now, when we are at this stage, primary school stage, the grammar stage, we need to find a way to take the concrete, where we're working with manipulatives, and we can then take that concrete where I'm like literally counting, how many pens do you have? You have 2 pens. If I take 1 pen away, now I have still 2 pens because I'm not giving this other pen away. So we take the concrete, we make it pictorial. Now I can draw a picture of the pens. And so that shows representation, which actually sets us up for saying, okay, there is a missing number here. 1 plus missing number equals 3. Okay? So now I can say, okay, well, 1 plus missing number, let's say that's 2 pens. Okay? In concrete. Then I can draw 2 pens, but then I can later replace that missing number with a block, or I can replace it with an X, or even a Y, or even a Z. So I can replace it with whatever. And that basically sets them up for later algebra. So it gives them the grammar to understand the concrete to pictorial to abstract progression. But it sets them up to later understand the place values of, or the placeholders, like an X and a Y. So then we obviously need manipulatives and real world examples. So I do a lot of my primary school maths, even with older students, just lifing. Involve them in life. And yes, we've got checkboxes to fill and whatever, but the real learning doesn't happen on a worksheet. The real learning is happening while we're shopping, and I'm like, which one is cheaper? I need you guys to go get me this. I'm in a hurry. I'm gonna go do this. You go do that. The real learning happens when I say, hey, you've got a birthday party. Your friends are here from this time to this time. This is your budget for your birthday party. What do you want to spend it on? Do you want a jumping castle, or what do you want? And they make those decisions on the benefits of each. and they look at what their run of show is for their birthday. And I love doing a run of show for a birthday. So in terms of some practical things that we can do, so weekly structure, every day, do 10 to 15 minutes of number play. Number play does not mean a tablet game. It means actually playing around with numbers. It might be they ask you random questions, random math questions, and then you get to match their complexity. Once a week, have a weekly session where the child teaches the parents. And if you've got multiple students, it's fun because then the child can teach their siblings as well, which gives them a bit of a boost, like an ego boost. But it's really fun. So the child teaches the parent. So I have my kids come and teach me something, anything. It doesn't always have to be maths. I do generally have them show me something in maths every week, but I don't push for things to be overly formal. So, yeah, that's the thing. And then calculators, just in primary school, I've got lots of calculators in my house, but like they live in my room. And the kids come and fetch my calculator sometimes because they play around with it. My kids learned a lot from calculators. But calculators, when we're actually working things out, when we go to the shop and we're working out how much groceries are, we don't take calculators with us. And that I show them by never taking my own calculator out. I don't know if I've opened the calculator app on my phone. I think I have once or twice, probably. So the thing is, if our primary maths is weak, it's going to mean that our IGCSE work is all going to be exam training, because we don't have time in a year and a half that we see, or year and a half to 2 years that I see a child in IGCSE maths. I don't have time to teach them how to add. I just genuinely don't. I don't know. Like, I can pick up some issues and I can fill some gaps, but if I'm trying to explain to them what an arithmetic sequence is, even if I use different words and I just say it's a sequence 1, 3, 5, and they're not understanding the logic because they haven't played around with the maths. The only solution there is exam training, and yeah, they're not going to actually learn to think. And if you've been exam trained for IGCSE, there's no way to pass AS maths. I don't know, maybe there is. I'm just terrible and just don't know how to do that. So IGCSE maths, that is where the real sorting starts to begin. So it really sees what you're able to do and what you're not able to do. And I don't think that what you're able to do and what you're not able to do is whether you're maths brained or English brained. I think that's absolute rubbish. I am equally passionate about maths and English, and languages, and pretty much like I don't think that you need to be held back by not having a maths brain. I think that's unnecessary. So when we are at IGCSE, what we're actually looking for is algebraic fluency. How well do you understand algebraic thinking? Because it represents a type of thinking. We're looking for types of thinking here, not the ability to solve questions. We're looking for types of thinking. So we're looking for algebraic fluency. We're looking for logical sequencing. How logically can you sequence something? Like, we're looking for spatial reasoning. Can they understand things in a space? Can they understand them in a context? And we're looking for clear and structured working. Can you have all these thoughts and then communicate them on paper? Because if you can have all these thoughts and communicate them, you don't own it. Okay? So at IGCSE, where we also have the Trivium, so we're looking at grammar. So your grammar at IGCSE is algebra, your notation, your formulae. Your logic is multi-step problems, where we take our algebra and we do multi-step problems and we do some functional thinking. Like, does this work? How does this work? What is a better option? So that's your logic. And then your rhetoric is your method marking. It's your how you've used your thinking skills to be able to solve this problem. How have you structured your argument? Because math is just an argument. I'm arguing that 1 plus 1 is equal to 2. And I can argue that. Okay. It's a very simple argument though. But we look at how you structure it. We look at how you interpret the question. Do you interpret the question on a deeper level, or are you just... And these are things that we're teaching them to do. We're teaching method marking. We're teaching structures. We're teaching interpretation. But we're teaching that through use. We're teaching that through inspiring their curiosity. Instead of... Sometimes it's important to say, hey, this is an interesting question, but what if we do this? Would the same thing still happen? We've told you that you should multiply and then divide. Well, divide and then multiply, depending on the system that you're using. But we've told them that you do it in a specific order, but like, does it really count? Does it always work? When does it work? When does it not work? What matters? What does not matter? Okay. So in terms of practical use of this at IGCSE, every day you should have like 20 to 30 minutes of short practice. Okay. This is like bare minimums, right? So you should have short practice. Not overly focused on worksheets and things. I really like Save My Exams because it's got some good practice. And then we've got weekly mixed problems, and these are not topic isolated. So the best way to actually do these weekly mixed problems is to work through past papers. So we're mixing the problems, and what that does is it connects the different areas of our thinking, because we don't only want to be thinking about algebra while we're or only wanting to be thinking about geometry. We want to be thinking about all of them at the same time so that our brains can connect the different concepts. Okay. And then monthly or weekly, I prefer weekly. I wrote here monthly, but I don't think that's ideal. I think a weekly explain your thinking session. So have your kids come up and actually explain it to you. So if you're working with a teacher or a tutor, have them, this is your responsibility as parents, really. Have your kids come and explain something interesting they learned in maths. Don't make it a big thing. Don't make it like, don't put too much pressure on it. But let them explain their thinking. Oh, you got that answer. Why did you get that answer? Where did it come from? So what I often do in class is I will solve a problem, and then I will get all of my students to send their working out. And then I know what the answer is, but regardless of what the answer is, I'll usually take a question that could be worked out, where you can make a couple of mistakes, and then I'll get the students to explain their thinking and then catch each other's errors, and then they fix it together. And that's pretty cool. So real improvement, how we measure our improvement at IGCSE, because that's a really big thing for people, measuring improvement. So we measure our improvement by seeing how well they explain what they're doing, because that shows whether they're actually learning. Okay. So if a student can only show you the things that they've been shown in class, oh, my teacher showed me how to work this out, that doesn't show learning, it just shows dependence. If the only questions they can work out are ones that they've seen before, like I've had students come to me often, all the time. Oh, I haven't seen a question like this before. I'm like, oh, great. So it's your first time seeing this question. Work it out. Okay. And it sounds a little bit harsh. Maybe it's a tad harsh, but like I'm no more harsh to my students than I am to my own kids. And my kids are great. So my students are great too. So the thing is, we figure it out. And there are different ways that maths can be taught. We can either let them drown and then show them how they drowned, which I don't think is always helpful because it just causes insecurity. But we can also just show them how it all works and put it all together for them, which is fine. Give them an example and say, okay, you're going to do these 3 examples exactly like my examples. Or I can show them the different components and say, okay, here's the logic. Let's apply the logic. Okay, cool. So now you've got the components. You've applied the logic. Here's some rhetoric questions. Let's see how you interpret it. Let's show your method. Let's show your method. Let me see how you take this thinking and connect this thing and this thing. I want to see what you're doing. And so it is actually quite labor intensive as a teacher because it requires me to think. But I mean, imagine if I didn't have to think, I'd get so bored. Okay. So next, AS Maths. So we've got pure maths, statistics, and mechanics. So maths is divided into 2 real categories. Okay, more, but like for our purposes right now, we're going to divide it into applied maths and theoretical maths. So theoretical maths is the thinking. It's where we work with imaginary numbers because we can't actually work with imaginary numbers. There are no imaginary numbers. But in theoretical maths, there are. Now, theoretical maths, the other word for that is pure maths. Okay? And then we've got applied maths, where it's actually used in the real world. So that's like statistics and mechanics. So we have statistics, mechanics, and pure maths. Now, at AS, you choose either pure and you choose pure, and then you can either do statistics or mechanics. Different students do different things. I prefer mechanics. I love mechanics. It's very sciencey, and I love science. So, I mean, statistics is also sciencey, but like, I prefer mechanics. I just enjoy it. It's very practical. That being said, so statistics. My argument is falling flat, isn't it? So, in terms of pure maths, what we're looking for is abstract reasoning. We want to see abstract reasoning. We want to see that if I give you an airplane, you can actually apply all these things and you'll be able to do a 20-step problem. Okay, probably not 20 steps. But then we've got algebraic manipulation. This is a really big one. And in English, I love teaching manipulation. That's all that English is sometimes. So algebraic manipulation isn't much different. I'm joking. Okay. Now, then we've got calculus as logical structure. So basically, at AS level, we show how calculus is a logical way to structure maths and to show it basically combines the graphing and the number patterns and things like that and algebra, and it combines a lot of different components. Then when we look at statistics, we're looking at interpretation over calculation. We want to see how students are interpreting. We want to look at how language and context are used. Okay, so it's very language-ish focused. Then mechanics, language-ish, imagine. Then mechanics, we're looking at how math is applied to our physical reality. Okay, so we're looking at vectors, motion modeling. And this is where we really see some weak algebra. So part of the reason I like mechanics is because I love algebra, I think. Oh, well, I think this is part of the reason. But I love algebra. So I love finding flaws in algebra and things like that. And so I think that's part of the reason I like mechanics. So the thing with AS Maths that people are struggling with is there's nowhere to hide your gaps. You can't hide your gaps between this thing and that thing because everything is working together. It's a system. It works as a system. And so it punishes your gaps. So what we need to do at AS Maths is have a slower pace. We need to have fewer questions, not more. We need to have deeper analysis. So instead of doing a paper in one day, we can spend a whole lesson on one question. And I do that often. My students love it. So then we need to have regular verbal reasoning. So in class, what I do is I have my students explain to me what to do. Like I'll be writing on the board and I'll have them explain to me what to do, and then I'll be like, okay, but why? And so as we go, then I'll write the little grammar things on the side because it's the terminology that we use. And so we need to make sure that the language is perfect so that if they understand their language, if they know their language, then they can use their language to explain what they're doing. And if they can explain what they're doing, then I'll actually believe that they know what they're doing. So how can we apply all of this? It's difficult because we constantly question ourselves. As parents, I know as a parent, I question myself far more than I do as a teacher. And I have taught many, many people, many kids, my kids' ages and older, but still I doubt what I'm doing with them. And it's difficult as a parent to kind of make these decisions for our kids because we have to make the decisions and we have to say, okay, well, we're going to go with this. But we also need to be able to say, you know, this decision actually isn't working for our family, so let's change it out. Let's change it up. And that's okay too. So I do a thing called process-led learning. So my mother is a play therapist. And so she is all about Gestalt and the process, follow the process. And I mean, it infected my brain. And so I watch the students' process. And so when we watch how our individual kids or students are working, we can see, okay, this is working, this is not working. So we don't need constant testing to see, do you understand? Because we see what they're doing. If we stay vigilant and we stay aware of what they're doing, we don't need to worry, right? So parents don't need as much support as they think they need, because we live in a world where we can find answers all over the internet for everything. So what parents need, in my opinion, what I built for myself was systems. So this is a system I use. I love the word protocol. So if my family ever wants me to do something, they're like, okay, here's the protocol. Oh my gosh, the word protocol is just like such a nice word for me. I love it. So we need protocols. How do we approach it when there is a problem? How do we approach it if my child or my student is not liking the way that we're approaching a topic? What happens if they're like, if I've explained in 5 different ways and they still don't get it? What is the protocol there? And so we need to figure out protocols. And so to do that, we really need to watch our families and our kids and our students. We need to see what works for them. And we need to put aside our own egos. So we need to put aside our own egos and just deal with the fact that maybe we're wrong. But that doesn't mean that we're constantly going to change it up. One of the biggest things that people struggle with when people I meet struggle with here is that they do one thing for 6 months and they're like, oh no, this didn't work. So then they start again, do something else for 6 months. And then they do 3 months with this tutor, 2 months on their own, and they don't actually commit to anything. So honestly, whatever you do, just do it. Choose what you're doing and do it and make small adjustments. Don't try to overhaul the system the whole time. Okay, so that is where textbooks help. That is where Save My Exams helps. That is where tutors help, because you are kind of like stuck on a journey. So take a journey and go on the journey. Okay. So if you would like help, like if you would like me to kind of help you figure out your plan, you can give me a call. Well, WhatsApp me and I will call you. I'll set up a call with you, and I'll help you come up with a plan. And yeah, so I can help you come up with a plan. Or you can come to me for tutoring. I have group classes. But there are also so many resources online. I use the Facebook group. I use I use a bunch of Facebook groups where there are a lot of resources. There are many independent resources for self-directed families, because not everyone is going to have the money or the ability or even the desire to work with a tutor. You don't have to. I think it helps, especially at AS level, and often at IGCSE, but I have seen many people do really well without tutors. But so there are many resources for self-directed families. You just need to look for them. So yeah, if you do have any questions, please feel free to email me. My email address is below. And you can also find me on Facebook, YouTube, everywhere, and just WhatsApp me. I've got my links there.